The next concept we need in our investigation of production technology is monotonic technology. We have a given production function. We will say that technology is monotonic if f is increasing in both arguments. Technology is strictly monotonic if f is strictly increasing in both arguments. We introduced monotonicity as a condition on preferences in a previous lecture, stating that preferences are monotonic if more is better. The principle is very much the same here. More production factors is better in the sense that the firm can produce more output if technology is monotonic. If the production function is monotonic, then it's increasing in x1, which means that the partial derivative of y with respect to x1 is greater than or equal to 0. That is, MP1 is greater than or equal to 0. For the same reason, MP2 is greater than or equal to 0 if technology is monotonic. If it is the case that the marginal products are strictly positive everywhere, then technology will be strictly monotonic. For all practical purposes, the opposite is true as well. However, we know that a function can be strictly increasing and still have isolated points where the derivative is 0, so the opposite is not true in a strict sense. Even though it is certainly possible for technology not to be monotonic, we argue that the marginal product of labor could be negative when we discuss the production of healthcare services if the amount of labor is too large. We will typically assume that technology is monotonic or strictly monotonic, since firms will never decide to use a bundle of factors if one of the marginal products is negative for this choice. One final result on this slide. If it is the case that technology is strictly monotonic, then every isoquant is the graph of a strictly decreasing function. x2 is a function of x1. You can find this function for an isoquant by starting from the production function and solve it for x2. Here is an example of technology which is monotonic. Y is equal to 100 times square root of x1 times x2. MP1 is 50 square root of x2 over x1, and MP2 is 50 square root of x1 over x2. MP1 and MP2 are both strictly positive for all values of x1 and x2, except for x1 equal to 0 or x2 equal to 0, and technology is strictly monotonic. Since technology is strictly monotonic, we know that each isoquant is the graph of a function, x2 as a function of x1. To derive this function for, say, y equal to 1000, we replace y with 1000 in the production function and solve for x2. Dividing both sides by 100, we have 10 is equal to the square root of x1 times x2, or 100 is equal to x1 times x2. And the function we're looking for is x2 is equal to 100 over x1. Having discussed monotonic technology, we move on to the next property, namely convex technology. Again, we start with the production function and we assume that technology is strictly monotonic. For a given output y, there is a downward sloping isoquant. Let's say that it looks like this. This isoquant is consistent with convex technology. To demonstrate this, pick two arbitrary points on the isoquant, x1, x2 and y1, y2. My x bundle and my y bundle. We produce the same amount with these bundles of production factors. The x bundle uses a lot of the second factor, while the y bundle uses a lot of the first factor. We draw a straight line between the x bundle and the y bundle, this blue line. Bundles on this blue line will be called z bundles. If it is the case that we always produce more output with a z bundle than we do with an x or a y bundle, and this is true no matter how we pick the x bundle and the y bundle on an isoquant, and no matter which isoquant we select, then we say that technology is convex. In our picture, the blue line is above and to the right of our isoquant, so the condition is satisfied. This will also be true no matter how you pick the x and the y bundle on the isoquant, so this isoquant is consistent with convex technology. For some choices, the blue line will overlap the isoquant, but that is okay because of the inequality greater than or equal to. With strictly monotonic technology, technology is convex if and only if every isoquant is the graph of a convex function. You probably recognize this entire discussion from the consumer theory, where we had indifference curves instead of isoquants. Let's have a look at the distinction between convex technology and strictly convex technology. Here is an isoquant consistent with strictly convex technology. Pick any 2 points on the isoquant, an X bundle and a Y bundle. We draw a straight line through these 2 bundles. If it is the case that this blue straight line is always strictly above and to the left of the isoquant, never touching it, with the exception of the X and the Y bundle, and this is true no matter how you pick the X and the Y bundle, and it's true for all isoquants, then technology is strictly convex. For the bundles that I have selected in this example, it is clear that this condition is satisfied, but you can convince yourself that the same will be true no matter how I pick the X and the Y bundle. So this isoquant, as opposed to the isoquant in the previous slide, is consistent with strictly convex technology. Of course, all isoquants must be like this for technology to be strictly convex. We have some results that will follow if technology is strictly monotonic and convex or strictly convex. These are very similar to the results we found in consumer theory. Actually, I have just made a copy of the slide convex preferences result and made a few changes. So now we have a 2 factors production model and technology is strictly monotonic and either convex or strictly convex. We know that a given isoquant is the graph of a function g where x2 is g of x1. We have the following results. First, g is strictly decreasing. If I increase the amount of my first production factor, I must decrease the amount of the second production factor if output is to remain the same. Second, G is convex if technology is convex, and G is strictly convex if technology is strictly convex. The way we define convex technology is precisely how convexity of a function is defined. Finally, if the isoquant is smooth, then the derivative of G is less than 0 everywhere, and the second derivative is greater than or equal to 0 everywhere. If the second derivative is strictly positive everywhere, then technology must be strictly convex. We say that technology is well behaved if it is strictly monotonic and strictly convex, the same term we use in consumer theory.